Today we're going to be working on Leetcode question number 300, longest increasing subsequence. Given an integer array nums, return the length of the longest strictly increasing subsequence. A subsequence is a sequence that can be derived from an array by deleting some or no elements without changing the order of the remaining element. For example, 3, 6, 2, 7 is the subsequence of this long one where here's the 3, then 6, then 2, and then 7. So this is still a subsequence of this array. So in this example the answer is going to be equal to 4 because the longest strictly increasing subsequence is going to be 2 and then 3 and then 7 and then 101. Our algorithm is basically what we're gonna be doing is like we're gonna have our array of we're gonna call it tails. uh, like it's gonna be an array, uh, and then we are gonna be updating it to kind of collecting all the all the like increasing uh, sequences. So let's just initialize it first. So int n is equal to nums dot length, and then our array size, our array tail is equal to new int of size n, and then our size is gonna be equal to 0. Okay, for every, so initially we're gonna say that the size is equal to 0, and then we're gonna iterate through this nums. Okay, iterate through the nums, and we're gonna every single time we're gonna initialize I equal to 0 and int j equals to the size. Okay, now again the tails is initially 0, and the size which we are interested in returning is also 0. So whenever we see a number, we say in the beginning we're gonna put it in the tail. When for the first integer we're just gonna say that okay, because we are gonna be looking at like at the smallest index of, so we're going to be looking at this ith index inside the tails and see if the new number is actually, we're going to compare the new number with the uh, with the with the tails array uh, at that particular at ith index. So depending on the comparison we're going to update that, and that is gonna be what we're gonna be doing. So initially for this every when we are iterating it, we're gonna say that while this I is not equal to j. So if that is the case, uh, which this is not going to be the case at the beginning because I is 0 and j is equal to size, and that is size is also 0, so we're not going to be entering here. So in the first entry this is not gonna be the case. So what we're gonna be doing is like we're gonna be saying that whatever is the value of tails of I, which is like we're gonna update it with the current element inside the array. So the first element, which is gonna be equal to 10 over here, is just gonna go to this tails was initialized as 0 0 0. How many times? 1 2 3 4 5 6 7 8, 8 times. 8 times, yes. So in the first iteration when the uh, nums is equal to this one, So something like this. Okay, yeah, along those lines. Okay, so when our x is gonna be here at 10, uh, I and j are gonna not gonna be like, they are gonna be equal, so we're not entering into this while loop. So and that x is gonna uh, become, so this is gonna, I think we are missing one more zero. Okay, so that's what's gonna happen in here, at the for the first element. And then we also wanna update the size. So if there is I is equal to size, we're gonna increment the size. This is the size is the thing which we are gonna be returning at the end. So if we know that, okay, the tail's first element is the smallest one, and you have gone through the processing of I until I become equal to j. If that is the case and I turns out to be equal to the size, we're gonna incrementing the size. This is basically the first thing is the I, and like the where we're gonna start processing it, and we're gonna go up to j, right? So up to j, if the I is increasing, that means like we are going forward and we are like getting a lot of uh, increasing numbers. If j is coming back, that means that we need to update the previous values. So while the I is not equal to, what we're gonna be doing is like doing a binary search here. Our middle point is gonna be I, like we're gonna just calculate the middle, and one way of doing that is like I plus j minus I, just to avoid the overflow. Okay, if like the, now the tail, now once we do the middle point, we want to check what is the value of that, like the tails of m. If it is less than x, that means we need to update. uh, so in order to update, we're gonna move our I to m plus 1. Else, that means that the tails of I, the tails of m is tails of m, which is already there. If it is greater than, sorry, if before that it was less than the new value, so we were just incrementing the I, that okay, you are good to go. Tails is already uh, in sequence, in an increasing sequence, so you can go and process the next element. But when that is not the case, and the tails of m is actually greater than the x, then we're gonna say no, the j needs to get updated and become equal to m, which is the point where we are at. So let's take an example on that. So the x in the first one, it's just simple, we're gonna update that, and the size is gonna become equal to 1, right? But in the next one, when the x has reached x is equal to 9, we are gonna say that we're gonna be starting with I equal to 0, and j equals to uh, j is gonna equal to size is 1. Okay, when we start over there, we are saying while they don't become equal, take the middle point, middle index, so that is gonna be again 0, and look at the tails of 0, which is this. Is that value less than the new value? Which is not the case. It is not less than that. Then that means we're gonna be updating j, and j is gonna become equal to 0 again. And in that case, tails of I, which is again 0, is gonna get updated again, so this is gonna remove, and we're gonna put x in it. And then the size is not gonna it's not going to change because I is not equal to the size, so the size is going to stay the same. Next time when it becomes 2, again the same thing is going to happen. This time the m is going to be equal to, because we start with 0 and then this has become equal to 1, because so we calculated that, and it becomes again 0, and we compare it, we update again. This is gonna be tails of m is not gonna be less than x, so we won't be updating I. That's a typo. I won't be updating I, we will be updating j. So again this is gonna become equal to 0, and we're gonna end up updating our tails. But then when we see 5 here, this time we're gonna start with 0, and this is like 1, because it initializes every single time to size. Okay, okay, so this time when we see 5 here, we are gonna say that okay, the tails of m is actually less than x. That is true. The 2 is less than 5 here, so we're gonna say that this time we're gonna be updating I, which is equal to m plus 1. So the m is gonna be the 0 plus 1, this is gonna become 1. So first of all, the thing which is gonna get updated is tails of I, which is 1. So this is gonna get updated to 5, and the more important thing is that this is gonna become 2 this time, because the I is equal to the size. So on and so forth. Looking good so far, and this should work, and it does.